You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey everybody, welcome to this week's show. Oh boy, it's just great to be here. How you doing, Rachel?
I'm doing pretty good. I'm pretty excited about my topic, mainly about my intro to the topic, but it's also just a really big topic. It's a little different than what I normally do. So,
well, everyone's gonna have to wait because guess what?
I know you
I get to go first. I'm actually going to build off of last week's topic a bit, so I hope everyone listened to the episode about the screaming grass, because last week I talked all about the smell that grass can give off and how it's actually like a form of communication. Obviously we know that.
Help me.
Yeah, we know that like lots of plants give off smells, right? And I talked about like how if you cut flowers, there's also other odors given off by plants, as anyone who has ever like cut up a fruit or been out weeding, has noticed. And so it brings up this kind of interesting question in my head. Since plants have so many smells and give off so many smells, can plants smell the smells they are giving off?
Ooh.
And the answer, of course, is no.
Okay.
Well, that's my topic for this week. My sources were... No, I'm just kidding. The answer is yes, Rachel.
What?
Yes, they can.
They can? I
Yeah.
thought you were like fully just playing with me and we're just going to have like a completely different topic. And I'm like, of course plants can't smell things, but they can smell things? That's insane.
Yeah.
What?
Plants can smell. Okay, let me talk about this a bit.
Oh my gosh.
It turns out there is research showing that plants actually can smell, which is like mind-boggling, since famously they don't have noses or olfactory glands or anything like that. Now, we think actually quite a few types of plants have ways to smell what is around them. And I have a pretty cool example that I want to share with you today, and it comes to us via the research done by Dr. Consuela de Morales, who's a biologist at Penn State University. And her colleagues and even her students have been doing some research on the dodder vine. And that's not daughter like son and daughter, but Dodder, the dodder. So dodder vines like to go after other plants and essentially feed on those plants and use them to grow. So it'd be very useful if those vines had a way to locate other plants. They're essentially like a predatory plant, right? Right. And these researchers think they have demonstrated that this vine is actually smelling its way toward other plants.
What?
Okay. Yeah.
How?
So
how are they doing this?
What
Kirk?
do they do? Like, how do they figure this out? Let's break it down. First of all, they conducted a number of experiments. They would grow a little dodder vine next to a tomato plant. And the vine would sort of start to kind of grow out of the ground and start to spiral around and grow and get longer. And eventually it moves over toward the tomato plant and touches it. And once it touches it, it's like, oh, great. And it starts to kind of grow up the tomato plant. And my first reaction, and there's videos of this online, like a time-lapse video you can watch. And my first reaction was, okay, hold on. This plant is just sort of
rubbing off,
searching around. Yeah, searching around in a circular pattern, and once it touches a tomato plant, then it's like, oh, hey, cool, something I can grow up, and that's even ascribing like, intelligence to it. It's like it's a physiological response. Like it hits something, it starts to twine around it, right? That's what vines do.
Right.
So I'm thinking this could just be a purely physiological thing. Doesn't prove there's any sort of smell involved, and fair enough. But they thought of that, and they did more experiments. So here's some of the things they tried. They tried it again, and this time with an artificial tomato plant instead of a real one. And also as a control, I guess, just an empty pot on the other side to see, would it grow toward one of these? And if it was just like a reaction to finding something nearby by chance, you would think it would behave the same way with a fake tomato plant. It sort of spiral around and kind of,
Right.
if you hit it, kind of bump into it, start growing. Well, it turns out that the daughter vine did not seem interested in either the empty pot nor the artificial tomato plants at all. So something interesting is going on there, that it was not attracted to the fake plant, which is right there where the real one had been. But of course,
Right.
it doesn't give off any smell. And so, it definitely did start to grow toward the real plant when they had it in that direction. So they tried more experiments, try to get, to the bottom of this. They tried having
I
the
love
real
science.
tomato plant be in the dark. So like it couldn't be any sort of visual cue. And even in the dark, the vine still grew toward the tomato plant. They also tried hiding the tomato plant behind sort of like a screen or something so that there won't be any visual cues or physical cues. And sure enough, the vine still grew toward the plant. And Morales also had her students do some of these experiments where they put the vine inside one box and the tomato plant inside another box and connected them by a small tube. So the only thing that could go back and forth between them was air. And sure enough, the vine, as though it could smell the tomato plant in the other box, started to grow toward that opening and toward the tomato plant, which is just amazing.
That's wild.
If you can't see a plant and you can't touch a plant, then you would think really the only thing that would be left would be smell. It goes further than this, though. So I was reading, they did some further follow-up studies trying to figure out whether or not the plants are picky, as in, can they differentiate different smells? Because that would also be like, okay, like, is there something that they're detecting there? And it turns out daughter will grow on not just tomato plants, but also on wheat plants. And so what her research was able to show is that the daughter actually has an affinity for, or you could say prefers to feed upon tomato plants. They would put a wheat plant to one side of a pot and a tomato plant growing on the other side in a pot, and then grow the daughter in the middle and see what would happen. And the daughter vine would start growing toward the tomato plants instead of the wheat plants, even though it's capable of feeding on wheat. The fact that it could differentiate, no, I'm going to go this way, I want to go over toward the tomato plant is
wild.
Pretty amazing. Now, I will say, anyone who is a gardener and has trimmed up a tomato plant, or if you pulled their relatives out, like the nightshades, it's all in the same family. What do you know, Rachel?
They have a very distinct, like, sharp smell.
Yeah, they are a smelly plant. And when you study them scientifically, you find out they actually have multiple different smell like chemicals in them that we consider attractants. The research I saw said that they found three different.
This makes me smell like
I can smell them right now, right?
Tomato.
Exactly. So apparently the plants have three different sort of volatile organic compounds in them that are an attractant smell. Whereas when they studied wheat, they only found one smell. And I guess, I don't think of wheat plants as having like an overwhelming smell.
I don't know if I've ever smelled a wheat plant,
Yeah, and so it's kind of interesting. What I wasn't able to figure out from my reading was whether daughter plants are more successful when feeding on tomato rather than wheat, which would be really fascinating because that might imply a preference for tomatoes as opposed to the tomato just being the smellier of the two. Like you see, it's like, oh, this is a stronger smell. I'm just going to go toward the stronger smell. But let's say daughter plants thrive equally well, on both. Yeah, okay, probably it's going to the smellier one. But if it's like, no, they also do better when they're on tomato plants, they start to go, so which is it now? Like, are they actually showing like a literal preference? They're going toward the one that's going to help them more versus just going toward the strongest smell. Either way, the fact that they're going toward smells is like mind-boggling.
I don't even know how they're able to do that.
Yeah, it'd be even cooler if they could show that it's like there's an actual selection for the better host, which wouldn't surprise me, but it would be even cooler. And I'm sad that I was not able to find that in the literature. Ultimately, I started off by asking whether or not plants can smell. And perhaps, I guess it depends on your definition of smell. Do they have noses? No. Do they have olfactory glands that detect smells? No. Do they have a central nervous system to transmit smell information? Again, no.
No.
And so it might seem reasonable to assume that they cannot smell, but similar to last week, we're completely stuck on this human model for what it means to smell, or in the case of last week, to communicate. And we're incredibly biased to consider smell only the way we do it, like with a nose, But of course, what we learn when we study nature is that there's more than one way to do the same thing. And this is a natural product of evolution. It is beneficial to be able to do certain things, but two species can't necessarily do things the same way, as they are different to start with and have different genes to work with. So this is even more radically true when it comes to plants as compared to animals. Like, they're working with much
100%.
different genes, right?
Yeah.
And so, yes, there's no noses or olfactory glands or even nerves to send those messages, but we now know that they can detect and react to smells, which is just strange, bizarre, and awesome. We live in an incredible world, people. Super incredible.
It's
What
so
I didn't
cool.
delve into really deep on this is the mechanics of how they're smelling. And I don't know. I need just more research on that. Like, I think that's kind of something we're still looking into, is the mechanics of how this is done. It's relatively easy to show that, yeah, it looks like they are using smell, but what I would assume
But
the biochemistry
biology or whatever
behind that,
How are they doing it?
I don't know.
Is it pheromone
I'm sure it's something that's
based?
being looked into right now. Possibly, but again, like, what? That's something that might be like a sort of smell that's given off. What is the receptor? What's the mechanism being used to detect it? If you don't have a nose, that's a question for another day. I will say my source this week was a really great story by Robert Krulwich, the amazing Robert Krulwich on NPR, that he did back in May of 2012.
Oh, thanks, Kirk. I'm going to be thinking about this.
You are welcome. I hope that... I know last week was all about like plants giving off smells to communicate. Now it's about this week about plants actually smelling those smells from other plants. And so I guess next time, I talked about mowing the grass last week. The thought I'll leave you with this time is, next time you lay down on a freshly mowed, lawn, just realize maybe the plants are smelling you back as you're smelling that grass. Like,
horrifying.
That's pretty weird.
I love
it's not
it,
horrifying.
though.
It's magical, Rachel. It's magical.
It is magical, but
but it's
feels weird.
outside of maybe what we're
comfortable with.
It does, because it's outside of our normal perception of how we think the world works. And so when you learn things like that, you go, "Gosh, the world is maybe different than I thought." And I find that exhilarating and exciting. It's why I do this show
100%.
ultimately, and why I share these things with all of you. Well, let's take a quick break, and we'll get Ray-Ban back, and we'll have your topic.
Mm-hmm. Welcome back, everyone. So this week, I have a topic that is about an organism that is absolutely surrounding you right now. Might even be in you.
Oh. Dun, dun, dun. Okay.
Let's talk about yeast, baby. Let's talk about all the good
yeast,
things.
Baby. Let's talk about you and me. All right.
Let's talk about all the good things and the bad things that it brings. Let's talk about yeast. So this has been on my list for a while, just waiting for the right time. And I think it's finally come up.
Just brewing in the background?
Just absolutely brewing
Just
in the
proofing,
background. It's just
leavening.
waiting for its time to rise.
Oh, there it is. There it is. Amazing.
And so good. And I definitely think that it'll come back again in the future after a second proof. But I do want to talk about yeast. So when people think about Victoria is going to be so sad she missed all of these puns.
These puns are for you, Victoria. This is what you miss out on by not being here.
We got you, Victoria. So when people think about yeast, generally they think about the stuff that is in their cupboard, right? Like I have some yeast in my cupboard, just hanging out,
Sure.
ready, waiting. That's bread yeast.
Mine's on my refrigerator, but absolutely.
Beautiful. I probably should put mine in the refrigerator, but it's fine.
If it's not, I buy it by like the jar, so I have to, once it's open, it's got to go in the fridge. Because as you're going to talk about, it's alive.
Yeah, it is. So that is, like you said, bread yeast, which since pandemic, a lot of people have gotten into making bread. On a very, very brief side note, I would love to make bread, but I've only done so successfully maybe once, maybe twice. And both somehow loaves of bread end up very dense. So any tips would be welcome in our comments. You can send them, say, hey, Rachel, here is a bread recipe. Thank you. So how many species?
I can help you bake some bread sometime. We'll do a little class.
Yes. So Kirk, how many species of yeast do you think there are?
Ooh. I know there's a lot of varieties of yeast, right? Like if you are doing beer making or wine making or champagne making, there's many different varieties of yeast. I don't know if you count all those as separate species or not. I'm going to guess it's in the hundreds of thousands. Like I'm guessing it's big, but I'm also prepared for you to say one. So somewhere between 1 and 1 million.
Oh, well, Congratulations, Kirk. You did it.
Yes.
You're correct.
How did I do?
So currently there's at least 1,500 species of yeast that have been documented, which is still quite a few species, but that's estimated to be maybe 1% of the species of yeast that are out there.
Okay. So throw a couple zeros on there.
We got some time. If you want to discover new species, it's yeast. Yeast, to break it down.
Man, I've been telling kids, at work that it's insects is where it's at if you want to discover new species, but
insects as well, microorganisms. Yeah.
Right. Someday you could be the world's leading yeast researcher, children. And not to disparage whoever the world's leading yeast researcher is, the person that's devoted their life to it, and it's awesome. It's just a little bit harder sell to children.
Just a little bit.
Since they don't know what
Insects are a little cooler. Yeah. So yeast is a living organism, like you mentioned. And generally, it lives in like a packet in your baking cupboard and in the air, but we'll get into it. So it is a single cell organism that is part of the fungi kingdom. It's its own branch within the fungi kingdom, yeast, which is wild because not a plant, it's a fungus. And it's single cell, but it does have like not quite a nucleus, but it's a eukaryotic cell that is very, 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 very tiny. So to get the little packet,
they're real small.
Little tiny grain is a little bit of yeast. And it's pretty much everywhere. Before humans domesticated it, they just bakers, whenever they would make bread or ferment beer or wine or any of those types of things, would just use what was in the air. They didn't know to add anything to it necessarily. And it is found everywhere.
I know that people still do that today. Or people do like make homemade like ciders and stuff, and they'll just do a airborne fermentation where you just let the air in, and it can either turn out amazing and like rich and complex and delicious, or just
the worst,
awful.
Yeah,
it's a little bit of a dice roll, but
there's reason for that.
People still do it that way.
Oh yeah. And it's found everywhere. It's found in the soil where it helps break things down, especially on like plant, like anything that produces any sort of sugar. It's in the air. It's on the skins of fruit. It's in our guts. It's even been found between our toes. And science recently-ish has even found yeast deep in the deep sea. So y'all thought I wasn't talking about the ocean?
Interesting.
Ha-ha.
Oh, here it is.
There
Sliding
it is.
back into the ocean. Dipping her toe into the water, and pretty soon, boom, she's in the
Ready.
bottom of the abyss.
I'm
Looking at
just
yeast.
hanging out. Yeah, they were looking at it, and I think they found some species of yeast. It was the primary, it was the dominant fungal diversity in the deep ocean. There was an article that I was reading that had a lot of really great diagrams and things that was done in 2007 in the National Library of Medicine was the journal, and it was yeast. Well, the title was Yeast Forms Dominant Fungal Diversity in the Deep Oceans, and it was done in 2007. But it's very fascinating. They were finding
I can just picture Rachel sitting in bed, getting ready to tuck herself in, and she's like, I'm going to pick up this journal here and read a story about deep ocean fungal colonies for some bedtime reading.
I mean,
that's the
they
most
found
Rachel thing I've ever heard of in my life, by the way.
Absolutely. They found it way down by the hydrothermal vent habitats. So it's deep ocean. Because there's been a lot of debate about whether or not to get into the ocean because we're talking about yeast. But I guess there's been debate about how how down at the hydrothermal vents, those are ancient ecosystems that have no recollection or comparison between here or between terrestrial environments or anything. And that article actually disputes that. Anyway.
Oh, wow. Okay, cool.
Anyway, so a little bit more about yeast. It's one of the oldest domesticated organisms that humans have, with evidence of yeast being used in some sort of baking, like a dedicated form of yeast being found on materials 4,000 years ago. So we've been using yeast for a very, very long time. And primarily when people talk about yeast, it refers to a singular species. All right. Saccharomyces cerevisiae, which is used in the baking of bread and a lot of the times in the fermenting of alcohol. It quite literally means the sweet fungus of beer.
Huh. Interesting.
It gets used, and that is generally when people talk about yeast, that's the species that they're talking about. That's the domesticated version, and they try to find new versions of this one and other wild types and try to regulate it so that way you can get a really distinct flavor. Because as you mentioned, Kirk, yeast generally works the same way, but because of how different species of yeast interact, it will come up with different flavors.
Mm-hmm.
So if you're using a different flavor or different type of yeast or strain in your fermentation, it can give you a different flavor. Generally speaking, yeast works because it eats the sugar and the starch. And as it's eating that sugar and starch, it's producing gas bubbles of CO2. And as it's eating that sugar, some of that yeast will also produce either gluten, depending on if it's the bread yeast, or over time it can produce alcohol, but it's still producing that CO2. It's absolutely wild. And not only that, but yeast has been used recently in engineering. It's a model in a lot of science, in a lot of it's a model organism for a lot of chemistry, experiments and everything. They actually were able to use yeast to make a biofuel recently out of out of ethanol, which is absolutely
ethanol
wild.
is, a lot of cars can run on ethanol, and so fundamentally that's made by a yeast. It's basically,
Yeah.
fermented and brewed, and yeah.
Yeah. And it's often used in aquaria, like aquarium hobbyists will use yeast to help,
Really?
I guess to generate carbon dioxide to nourish plants that are in there, I suppose. So it's a widely used alternative for a lot of
wow.
I didn't know that either.
I had not heard about that.
Apparently it's a well-known alternative, which is wild. It's also been used to help produce various drugs and even some, including like insulin. It's been used for helping to produce vaccines for like hepatitis. Yeast is used for a lot of things, and I will probably have to talk about yeast again because it is a giant topic. And I started looking into it a little bit more because it doesn't even I haven't even touched base on the fact that there are some species of yeast that are like pathogens that can cause infections. Like yeast infections are a thing.
Absolutely.
And that's a fungal infection that affects humans.
Thrush. Thrush
absolutely.
is a yeast. Yeah.
Yeah. So there's so much to talk about. There's even been some symbiosis found with yeast and like the nectaries of flowers within like the stomachs of some honeybees that was found in like India. It was wild. There's so much to talk about with
Interesting.
yeast, and I thought I could cover like more of it, but obviously this will probably
this is just like a shot across the bow telling everyone, hey, more yeast specific topics are coming.
Absolutely. But I wanted to give everyone a good basis of what yeast is in the first place because, I mean, I just think of it as that thing in my cupboard. I never really think too hard about yeast. And then, well, yeast. I got into it a little bit more. So it's really, really cool. It's everywhere. It's between your toes. It's in your guts. It's in the guts of honeybees. It's in your cupboard. We'll talk about it again. It's in your beer. It's in your bread. It's in the air.
And your beard.
It's in the soil.
It's everywhere.
It's everywhere.
Cool.
So that's what I have for us this
It's a
week.
fascinating topic. I hope we touch base on it again because every one of those specific areas could have its own. Maybe someone will start the yeast podcast. I don't think that would probably get a lot of clicks. The yeast podcast.
I don't think so either.
Who knows? The public is fickle, so
it's wild.
Yeah, probably don't make it.
I
guess if someone wants to make a podcast all about yeast, you know what?
I would listen.
It would find an audience of some size, especially if you talk about the ocean yeast. Rachel's in.
I'm already in. I'm there.
She's already in the ocean. All right. Well, thanks, Rachel.
Yeah, of course. My sources this week are Wikipedia, the journal that I mentioned, King Arthur Baking, had some really good, solid information about yeast, surprisingly. And then exploreyeast.com also had great
but there's an
great information about yeast.
Wow.
There's an exploreyeast.com. So thanks everyone for listening. We'll see you next week with Victoria.
Bye everyone.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.